Welcome students to our chemistry class. Today we will discuss about the chemical properties or chemical nature of water. Last class we have discussed about the physical properties of water. Chemical properties, within the chemical properties, first we will discuss that when water is treated with litmus paper, then what will be the change in color of the litmus paper. It has been observed that when water is added to the litmus paper, there will be no change in the color of the litmus paper is observed. It means if it is blue in color, it will remain blue. If it is purple, it will remain purple, and if it is red in color, it is red. It means the water is neutral towards litmus. Next is that about the stability of the water. When water is heated, it will not decompose easily and give hydrogen and oxygen. It will decompose, and that is near about 0.6%. When it is heated to 2000 degrees Celsius, then it will produce hydrogen and oxygen. But when it is treated, when it is by electrolysis method, when water is treated, then it is observed that water decompose and give hydrogen and oxygen. So it is highly stable. Next, catalytic nature of water. Now we will discuss about the catalytic nature of water, that sometimes water acts as a catalyst for some of the reactions. Like for example, when water is treated, when hydrogen react with the chlorine in presence of sunlight, then actually it gives hydrogen chloride gas. But if the reaction is carried out in presence of moisture, then and then only this reaction takes place. Here moisture is acting as a catalyst. In presence of moist hydrogen, react with moist chlorine in presence of diffused sunlight, gives hydrogen chloride gas. In the same way, when phosphorus burn in oxygen, then actually it gives phosphorus pentaoxide, P2O5, white fumes of phosphorus pentaoxide. When phosphorus reacts with oxygen, it forms phosphorus pentaoxide. White fumes of phosphorus pentaoxide is obtained. But if this reaction takes place only in presence of moisture, if little bit moisture is there, then the reaction is very fast. So moisture, since this reaction as well as this reaction takes place in presence of moisture, so the thing is that moisture is acting as a catalyst in these reactions. Next we will discuss about the action with the metals, means how metals react with the water. Sodium, potassium and calcium, these three metals react with the cold water. These three metals react with cold water. But magnesium react with boiled water. And then aluminium, zinc react with the steam. When steam is passed through hot aluminium or hot zinc, then they will react with the water. Iron, lead, these metals also can react with the water, but if these metals are red hot and steam is passed through these metals, then they will react with the water. Means under which condition? That they are red hot, then they will react with the steam, and after that the products are formed, that I will discuss later on. And other metals, if I think about copper, mercury, silver or gold, then these metals won't react with the water. Either they are red hot, or when steam is passed through, these metals, then even they will not react with the water. Now we will discuss in detail about the reaction of the water with these metals. The first is that the sodium. The sodium metal is there. Or potassium, then potassium, calcium. Sodium and potassium react with the water vigorously. Sodium and potassium metal react with the water vigorously. First thing. Second thing, they react with the water violently as well as vigorously. So when sodium and potassium is added to the water, what do you observe? That sodium as well as potassium, first they will float on the surface of the water. Okay. After that, they will form the dart on the surface of the water. And after some time they catch fire. Sodium burned with the golden yellow flame, while potassium burned with the lilac flame. So sodium and potassium react with the water and produces sodium hydroxide and potassium hydroxide. That is why whatever the solution is formed, when it is touched, it is little bit soapy in nature, soapy to touch. It means that is alkaline, and along with that, when litmus paper is added to that solution, it has been observed that the red litmus paper turns to blue. The red litmus paper, when added to that, whatever the product is formed, that solution, then it will convert it from red to blue. It means the solution is alkaline in nature. Actually, what happens when sodium and potassium react with water? They react with the water, cold water. And the reaction is exothermic in nature, and they produce after the reaction sodium hydroxide NaOH plus hydrogen gas, and this also produce potassium hydroxide plus hydrogen gas. The reaction is exothermic in nature, so whatever the hydrogen is produced, that will catch fire, and that is why the sodium burn with a golden yellow flame and potassium burn with the lilac flame. And when calcium is added to the water, then it won't float on the surface of the water initially it sink, because it is little bit heavier also, so it will sink within the water and form a solution that is of calcium hydroxide plus produce hydrogen gas. This is also exothermic reaction. Now this calcium hydroxide is little bit sparingly soluble in water, so whatever the solution is obtained, that is little bit milky, means milkiness is there within the solution. So sodium and potassium react with the cold water and they react violently, and calcium reacts with the cold water vigorously. The reaction is little bit slow compared to the sodium and potassium, and sodium react with the water, produce sodium hydroxide, potassium react with the water, form potassium hydroxide, calcium forms calcium hydroxide. Along with that, these metals react with the water, produce hydrogen gas. All produce hydrogen gas. We can identify the hydrogen gas when a burning splinter is brought near the hydrogen gas, then the gas will burn with a pop sound, pale blue flame and pop sound. The hydrogen gas will burn with a pale blue flame and pop sound. Next, that the metal magnesium, aluminium, zinc or iron. If we will discuss about this, magnesium reacts with the boiling water and even it can react with the steam. When steam is passed through hot magnesium ribbon, or when steam is passed through hot aluminium or hot zinc, then all of them will react with the steam. This also react with the steam, and this metal also react with the steam. and after reacting with the steam, this will give magnesium. This will form magnesium oxide plus hydrogen, and this will produce aluminium oxide plus hydrogen, and here zinc react, form zinc oxide plus hydrogen. So in these metals they will give oxides of the metal, and along with that hydrogen gas is produced. And when treated with the iron will steam when passed through iron, red hot iron. What type of iron? Red hot. Not only hot, red hot iron, then it will give the red hot iron, and it will form a mixed oxide, that is triferric tetroxide plus hydrogen gas. And this reaction is the reversible one. When steam is passed through red hot iron, then it will produce triferric tetroxide plus hydrogen gas, and the reaction is reversible one. So here in these reactions, oxides of the metal along with hydrogen are produced, but in sodium, potassium and calcium case, hydroxide of the metal and along with that hydrogen is produced. Now we have to balance all these equations. So this is 3Fe4H2O will give this one, and zinc oxide plus hydrogen already balanced. This one is, you have to balance this one, 3 and 2. Magnesium, this one is a balanced one. Okay. Sodium and water, sodium hydroxide and hydrogen. So we have to balance this one. This is hydrogen. To balance this one, if I write it here, this 2, then this is 2, and this also 2. Now it is balanced one. In the potassium also balance this. So this is balanced one. And calcium hydroxide, now this is balanced. So we have to balance the equations. Next is that if copper, mercury, silver or gold, these metals won't react with, no reaction with water. Either it is in the steam form or you are passing through red hot metal, no reaction will take place with the water. With which metals? With which metal? Copper, mercury, silver and gold. So since these metals react with the cold water, these react with the hot water or the steam, and these won't react with the, so we can arrange the metal according to their reactivity, and that series is known as the activity series. So metals are arranged according to their reactivity in a series, that is known as the reactivity series, where sodium, potassium, calcium, after that magnesium, aluminum, zinc, iron, then lead, tin is also there, copper, mercury, silver and gold, and then platinum is there at last. Platinum and gold, that is why we call it noble metal, because they won't react with most of the substances. Now next we will discuss about how these metals react with, the reaction of the water with the non-metals. Reaction, generally water won't react with the non-metals, but we will discuss with the carbon and with the chlorine. With the carbon and with chlorine. When steam is passed through white hot coke, then it will produce a mixture of carbon monoxide and hydrogen in the ratio 1:1, and that is known as the water gas. So when steam is passed through, carbon is there, white hot coke. Carbon in which state? White hot coke. When steam H2O is passed through white hot coke near about 1100 degrees Celsius, then it will give a mixture of carbon monoxide and hydrogen, and this mixture is known as water gas. The mixture of carbon monoxide and hydrogen in the ratio 1:1 is known as the water gas. Next we will discuss how water react with the chlorine, the reaction of the water with the chlorine. The reaction of the water with the chlorine is that chlorine react with the water, means when chlorine is added to the water, first it will in the dark, when it is dark, then it will react with the, it will actually dissolve in water and form a solution that is known as the chlorine water solution, and that is greenish yellow in color. Now when this solution is kept in diffused sunlight, then it will give a mixture of hydrochloric acid and hypochlorous acid in diffused sunlight, and when it is kept in direct sunlight, then it will produce hydrogen chloride gas and oxygen. So when chlorine is added to the water in dark, then it will give greenish yellowish green solution of chlorine water. Now when this chlorine water is kept in diffused sunlight, then it will give a mixture of hydrogen chloride gas and hypochlorous acid, HClO, hypochlorous acid. And this chlorine water, when kept in direct sunlight, then it will give a mixture of hydrogen chloride gas and oxygen. So the reaction is that the chlorine water, this chlorine and water, diffused sunlight, then it will give HCl plus HClO, hydrochloric acid and hypochlorous acid. And this chlorine, when treated with the water and if kept direct sunlight, then it will give HCl plus oxygen, HCl and oxygen. Okay, so this is all about the action with the non-metals. Now we will discuss about the action of water with metallic oxides. Action of water with metallic oxide. Water when treated with metallic oxides. Metallic oxides means like sodium oxide, potassium oxide, calcium oxide, magnesium oxide, zinc oxide. So these are metallic oxides. So only sodium oxide, potassium oxide plus and calcium oxide, when they are treated with the water, they dissolve in water and form hydroxides of the metal. Like sodium oxide dissolve and form sodium hydroxide, which is alkaline. Potassium form potassium hydroxide. In the same way, calcium form calcium hydroxide. Calcium forms calcium hydroxide. So these three metals, metallic oxide, react with the water, form hydroxides of the metal. They are alkaline in nature and they will turn the red litmus blue. But other oxides, if magnesium oxide, iron oxide, they will not react with the water. They are insoluble in water. They will not dissolve in water. They are insoluble water. That is why they are known as bases. While sodium oxide, potassium oxide, calcium oxide, since dissolve in water, so we call them alkali. Bases which are soluble in water, they are known as the alkali, and only sodium, potassium and calcium oxide, these bases are soluble in water and form the alkali. So metallic oxides are also known as basic oxides because they dissolve. Metallic oxides are also known as basic oxide because when they dissolve in water, they turn the litmus paper from red to blue. It means they are alkaline. So metallic oxides are also known as basic oxides. Next is that when water, action of the water with the non-metallic oxide. Non-metallic oxide, when water react with the non-metallic oxide, then they will produce acids. They will give acidic solution. Like for example, when carbon dioxide It is a non-metallic oxide. When dissolved in water, then it will form carbonic acid, H2CO3, carbonic acid, which will turn red litmus blue, It means it is acidic. In the same way, when sulfur dioxide is dissolved in water, added to the water, then it will form H2SO3, sulfurous acid. Phosphorus pentoxide, another non-metallic oxide, when dissolved in water, then it will form H3PO4. It will form phosphoric acid. So non-metallic oxide, when dissolved in water, when added to the water, then they will form the acid. It means the solution is acidic in nature. So non-metallic oxides are also known as acidic oxides. Metallic oxides we call generally the basic oxides, and non-metallic oxide acidic oxide. From carbonic acid, when water is removed, then it will give carbon dioxide. So carbonic acid is produced when carbon dioxide treated with the water. So we can say even carbon dioxide is the anhydride of carbonic acid, sulfur dioxide anhydride of sulfurous acid, phosphorus pentoxide anhydride of phosphoric acid. Sulfur trioxide is the anhydride of sulfuric acid, because when water added to these non-metallic oxide, then they are converted into the acid. It means water molecules are removed from those acids, then they will give you the non-metallic oxides. So these non-metallic oxides are even known as the anhydride of that particular acid. Like suppose, what is the anhydride of phosphoric acid? Your answer will be phosphorus pentoxide. Anhydride of carbonic acid, carbon dioxide. Anhydride of sulfuric acid, it is sulfur trioxide. Okay. So this is all about, we have discussed about the chemical properties of water. Now we will discuss about tests of water, or you can say how we can identify whether the given substance is water. So first we can identify the water by some of the physical taste or physical nature, that it is, first is that pure water is colorless, odorless and a tasteless liquid. It has no color, no odor and no taste. Second is that pure water, if water is 100% pure, then it will boil at 100 degrees Celsius at 1 atmospheric pressure. So by knowing the boiling point of a given liquid, we can identify whether it is water or something else. Next is that pure water freezes at 0 degrees Celsius at a pressure of 76 centimeter of mercury. That is, the freezing point of pure water is 0 degrees Celsius. It means the freezing point and boiling point of water. What is the importance? That we can identify or we can get the idea about the purity of the water. Next we will discuss about the how we can identify the water chemically. Chemically, how we can identify the water. With the help of copper sulfate salt and with the help of the cobalt chloride salt, we can identify chemically that whether the given substance is water or something else. So first is that with the how we can identify with the help of copper sulfate. For that, little bit moisture when it is passed through anhydrous copper sulfate. Actually anhydrous copper sulfate, when there is no moisture at that time, anhydrous copper sulfate means it is CuSO4. So that is white in color as well as amorphous. Amorphous means it is powdery. But when moisture is added to this copper sulfate, anhydrous copper sulfate, then its color converted from white to blue. At that time, actually this CuSO4 by absorbing or by reacting with the water converted into CuSO4.5H2O. So the white anhydrous copper sulfate, which is initially white in color and amorphous, when moisture is added to it, it will be converted into the blue color and crystalline form. So we can easily identify the water whether in the atmosphere or somewhere moisture is present or not. When moisture is passed through copper sulfate salt, then actually what happens? The white color of copper sulfate, white amorphous copper sulfate converted to blue crystalline copper sulfate. Next, we can identify the water with the help of cobalt chloride. Anhydrous cobalt chloride is blue in color. Anhydrous cobalt chloride, what is the color? It is blue in color. But when moisture is passed through it, then the color changes from blue to white. Anhydrous cobalt chloride, which is blue and crystalline. Anhydrous cobalt chloride is blue in color, but it is amorphous. And when moisture is passed through this cobalt chloride, anhydrous cobalt chloride, it converted to the hydrated cobalt chloride, CoCl2.6H2O, and at that time it is pink it has pink color and it is crystalline. So copper sulfate, CuSO4, this copper sulfate is actually white and amorphous. Amorphous means it is powdery form, no definite geometrical shape. When water is added to this, either in the steam form or in the moisture form or humidity form, whatever, or water vapor form, when passed through the copper sulfate salt, then it will form CuSO4.5H2O, and at that time it is blue in color and crystalline. Crystalline means definite geometrical shape. And if it is cobalt chloride, CoCl2, plus water is added to it, then it will form CoCl2.6H2O. The cobalt chloride, when it is anhydrous, means in the dry state, at that time it is blue in color and amorphous, means powdery form. But when moisture is added to it, it will give pink color salt. The salt is converted to pink in color and it is crystalline. So with the help of copper sulfate and cobalt chloride, we can easily identify whether moisture is present or not somewhere. So this is all about the identification of water. So how we can identify water chemically. So this is all about the chemical nature of water.